All right, guys, good morning. Hey, it's Monday morning. Don't forget, this week we've got worksheets 7 and 8. We're kind of combining a lot of units for you guys to kind of decrease the amount of work, and we're not really thrilled with the way the book presents the information. So this is pretty much section 4.7 and 4.8, but when you look at it to maybe revise your notes or whatever, don't worry about the rational root theorem and don't worry about Descartes' rule of signs. That's something that you really don't need, because what we use, instead of those two, what we use is we use Desmos, or we factor, or we use synthetic division with one of these. Synthetic division, or it's also called synthetic substitution. I think in 4.7 it's called synthetic substitution. I'll talk about that in a minute. So if we're looking at this, and I give you guys this equation right here, it's basically the same idea as factoring x plus 6x plus 8 equals 0. Okay? So it's the same concept as this, factoring that particular polynomial, except you have an x to the fourth and an x squared. So our answer looks a little different. So if you plug it into Desmos like it says for you guys to do, you get a graph that looks like this that doesn't cross the x-axis. That means that all solutions or zeros, all solutions or zeros are imaginary. So you're going to get that little I in your answer. So when you graph it, you're going to be like, okay, there's no real ones, there's only imaginary. Now, I'm just going to tie it into something here real quick. So there's only imaginary. So now we know now that when we factor this and set it equal to 0, we're going to get i's. The answer is going to be i's. Now, the reason we know this is because we can look at the graph, because we have these cool tools at our disposal like Desmos. We can plug it in and go, okay, yeah, it doesn't cross the x-axis, so I've got only imaginary numbers. I can't spell today. Only imaginary numbers. Well, Descartes' rule of sign and the rational root theorem, they actually do that by hand, and it takes a while. And then if you have 5 changes of signs, you got 2 zeros, and it's all these really kind of crazy little pieces where these take a while, and we don't really need them right now. But when you move forward, you can just plug it into Desmos. That's why we don't use these, because we can look at Desmos and come up with the same information. So we're using technology. So I did it a little differently for you guys because I wanted to introduce factor by grouping. So a lot of you would use the box method on this to factor this. I'm okay with that. You can stick with that. I'm going to kind of change it up a little bit because there's a thing called factor by grouping that you have to be able to do. So if we look at this, what I did here, if you guys can kind of see, let me find a better color here. Let me find my orange one. Let's use the black one here. I don't know where my orange one went. Let's look at this right here. Look at these right here. Okay? Those would be the two middle numbers that go here, 2x squared and 4x squared. Why? Because 2 times 4 makes 8. 2 plus 4 makes 6. So it's really the same idea of using the area model or the box method, but we put it in a linear format so we can do what's called factor by grouping, which is what I showed you guys last week, where we had a red group and a blue group, and then when we looked at them, we said, oh, okay, well, in my red group, what can I factor out? Well, I can factor out an x squared, and that's going to leave me with x squared plus 2. What can I factor out in my blue group? I can divide all of them by 4, so I get plus 4. And that gives me 4 divided by 4 gives x squared. 8 divided by 4 gives me plus 2. And since the two different colors here, I get x squared plus 4. And then those stay the same, x squared plus 2. So that's how you do factor by grouping, guys. Again, these two numbers here are what would normally go in the box method or the area model. 2 times 4 is 8. 2 plus 4 is 6. It's a little different way to look at it, okay? So, now we would take these and we'd set them equal to 0. X squared plus 4 equals 0. That means x squared equals negative 4. If I took the square root of both sides, I get x equals plus or minus 2i because of that negative. Look at 2i, they're imaginary. Only imaginary answers. I'm proving the fact that this only has imaginary answers. X squared equals 2. X equals, take the square root of both sides, x equals plus or minus I root 2. Oops, sorry, this is a negative right here. And that's a negative. The square root of the negative is an I, and then we don't have to know the exact value of root 2. It's like 1.7 or something like that. So those are my two answers. Look, we only wanted imaginary. We got imaginary answers because it doesn't cross the x-axis. All right, so that's kind of how you tackle finding zeros and different pieces using Desmos. And that's a little intro on factor by grouping. Now, if we work our way forward and we say, okay, well, let's say find the value at x equals 2 if f of x equals x cubed plus 4x plus 2. Okay? So, normally what you guys would do is you take this and you plug it into the calculator, and in the calculator, if you had one, you'd put in 2 cubed plus 4 times 2 plus 2, and that would give you an answer. So it's 8 plus 2 equals 16, 18. You would just plug it into the calculator and you'd get that, or you do it by hand like this. Well, I'm going to show you a different method you can do, and it's synthetic. It's literally the same thing as synthetic substitution or synthetic division. This is called synthetic substitution. Substitution, I think I spelled that right. We'll figure it out here in a minute. So, look at, I got x equals 2. So x equals 2. I draw my upside down piece for synthetic division. I put in my coefficient, which is 1. I'm missing x squared, which is 0. I put a 4 in. I put a 2 in. So we've got x cubed, x squared, x, and our constant. So that's what we did before. We bring down the 1. 1 times 2 is 2. Add those together. 2. 2 times 2 is 4. 2 times 4. 4 plus 4 is 8. 8 times 2 is 16. 2 plus 16 is 18. Same exact answer. Okay? So, when you finish these, your remainder is your output. Okay? So when you plug in an x here, your remainder is your output. So there's one caveat to that. So if you look at it this way, if I plug in x, if I plug in x and y, if I plug in x equals 2, my y is equal to 18, which is exactly what I got if I plugged it into the calculator. So synthetic substitution can help you move quickly without a calculator. Now, here's the big thing we use this for. If your remainder is equal to 0, then x is a root or x-intercept. Okay? So that's just a quick introduction. We're going to talk about it in the next video. So if I do synthetic division or synthetic substitution, if I get a remainder, that's your output. So if I plug in 2 and I get out 18, that's my actual answer. The ordered pair is 2 and 18. If I get a remainder that's equal to 0 here, so if this was 0, then the x value is a root or an x-intercept. So if this was 0, that would be a x-intercept. Okay? That's called the remainder theorem. Right? The remainder theorem. Quick introduction to the remainder theorem. Alright guys, that should get you going this week. And I'll have another video up this afternoon. Good luck.